Hi everybody, my name is Mutuana. So without further ado, let's get started. Okay, so let's move this calculator to the other side because we don't want it here, okay? So let's just move it to the other side. So move to the other side and let's get started. See? So, we have to start with our slogan phase. Never skip a practice day. If you don't, hey, you gonna fail, hey. Easy play, easy, man. Let's get started, man. So now the question here, they say a ball P. Oh, so we have a ball P, which is this one here, and then of mass 0.6 means, oh, this ball has a 0.6 mass moving to the east. So to the east means positive. You can see the arrow here say move to the east. Okay, so we have initial speed equal 6, and then initial speed equal to 10, not 6, and then it collide heads on with another ball Q. Oh, so the ball Q come to the west. It means its velocity is negative. How do I know? Look, we lane from grade 2, grade 3, like, okay, if anything move to the left, oh, sorry, my apologies, sorry. Okay, so we learn from grade 2, grade 1, grade 6, like, okay, if we have a number line, anything when you move to this side means you go to the negative, but if you move to this side means you move to the positive. Okay, so then we're gonna say now they have said, not we're gonna say, so the ball Q moved to the left, so this is negative. Okay, so this is before the collide, so this is a collision point we are shown. So after the collide, after collision, we see ball P, it moved to the left. So it seems like ball Q was very powerful. You can see this is 15, this is 10. So when they collide, obvious this is going to be more powerful, but sometimes it depends on the mass of objects. See? So even though Q has 0.2, this has 0.16. No. This is bigger because it has a bigger velocity initial and it had also bigger mass. But this is just 0.16. Can you see? Mass is smaller, but this is 0.2. So this has a bigger mass compared to this plus bigger velocity. That's why when they collide, P was way less powerful compared to Q. So this is kind of get bumped, boom, and then it still go back to where you come from. See? Now, let's get back to our business here now. So we have a mass of P 0.2. Now moving to the waist at the speed O after the collide, after the collision head on this water. After collision, that's what happened. So we don't know the direction of Q after the collide. See? Now we go. But me, I can predict, but it's not good to predict. Let's work it out and see the reality or how the answer comes. But if you can look carefully, you know this is going to go that way because look, it has a bigger velocity, it has a bigger mass. Smaller mass, smaller initial velocity. So when they bump, they move to, but now let's do mathematical. Okay. What is the momentum in words? Momentum mathematics equal to mass times velocity. See? So momentum equal to mass times velocity. See, so linear momentum of an object is the product of mass and velocity. So we can simply say here linear momentum, linear momentum of an object. So linear momentum of an object. Never mind my handwriting. Sometimes it can be messy a little bit. I'm trying to be a doctor here. Linear momentum of an object is what is that? Products. Is the product of mass times velocity. Product of mass and velocity. That's what gives us what? Linear momentum. Oh, so now we know. So in other momentum equal to mass times velocity. So the first one we done. Now for the second one, now they say find the velocity of ball Q after the collision. So now you're gonna have to apply the law of the conservation of momentum. What is the law of conservation of momentum? So we have a little formula here. Say from the law of conservation of momentum, we say momentum before collision equal to momentum after collision. So from the law of conservation of momentum, we say law of conservation of momentum, rule or law, we say momentum before collision, momentum before collision equal to momentum after collision. So what does that mean? Now let's go. So we know momentum will represent using mass times velocity. Momentum before collision, what does that mean? Initial. So it's okay. Mass times velocity, but a mass of P times initial velocity of P. So U of P what? Initial plus. So before collision also we have a mass of Q and initial velocity of Q. So we can say mass of Q, initial velocity of Q. That's before the collision. Let me drink some water a little bit. Sorry about that. Okay. Okay. Excuse me. So this is equal to momentum after collision. So now we deal with the final velocity. This was initial velocity of Q. Now mass of P, velocity final of P, velocity P final, let's say velocity of P, what final? Plus mass what of Q means of this one with the final velocity, which we don't know. Final F. F is final, I is initial. Okay. So now what we're gonna do, we're gonna substitute in the value that we have. Okay. So because you know why they move with a different velocity. But sometimes it happens in a situation whereby, let me show you, sometimes it's not going to be the same. It happens in a situation whereby, let's say they collide and then they move with the same velocity. For example, haven't you ever seen in a movie or in a real life where, or in a football or in a rugby or in sport, somebody go, let's say, run and then they bump each other and they move together, even the car, boom, they move together, means they move with a common velocity. So if it happened in that situation, means after the collision, means this is not going to be the same. If it happened like that, means after they collide, they move with the same velocity, means this, it wasn't going to be final velocity of P, means it's going to be V, and here's going to be single velocity. So everything was going to be the same, means V was going to go out, and then I'll say what? Mass of P plus mass of Q. You know why I take Q out? V out, because it was gonna have the common final velocity, means it's gonna be V. But for this case now, no. Everybody move with a different velocity. We see P was moving with its own velocity, and here we don't know which velocity move. They were not bind one another. Okay? So this is not the case, but most of the time, sometimes they ask you this, where they have the common velocity. So now let's just focus on what they have asked us to do. Okay? So now we want to say, now let's substitute in what we have. Mass of P initial equal to 0.16. Okay. Times velocity initial of P equal to 10. Plus. Okay. We go now. We want to get what? Velocity initial of P. Velocity. Mass of Q. What is mass of Q? Equal to 0.2. Times velocity initial of Q. 15. But look, this 15 moved to the left. So this has a negative because moved to the left. So we're going to say 0.2 times negative what? 15. Equal mass of P. What is mass of P? Now, this is after collision now. So after collision now, mass of P, we know it's going to be the same one, 0.16 times velocity of P final. What is velocity of P final? Negative, because this is after the collide. Look, can you see it's moved to the left here? You can see they say this move to the left after the collide P. So we're going to say times negative what? Negative 5 plus mass of Q. What is mass of Q? Mass of Q is going to be the same, negative, just 0.2 times velocity final of Q. But we don't know where it's going to move here. There was no even direction, or they didn't give us. So I can say what? Velocity of Q final. So that's what we're looking for. See, velocity of ball Q after the collision. Means this is after the collision on the right. So we can work it out. So how are we going to work it out? First, you have to put this in a calculator. So come into a calculator and plug it here quick. And then clean your calculator quick. And say, hey, you, come here, please. Plug you in a calculator quick. Okay, clean this. And then we say 0.16, so 0.16, and then we multiply by 10, and then you can say, oh, I can just come and put bracket here quick. They close the bracket, and then that's gonna be good. And then what we do with plus, okay, plus what? 0.2, and then we multiply by what? By negative 15, because it was moving to the left. That was before the collision. Come on, come here close, man. Time. Go, we got it. Okay. So this is going to give us negative 1.4. Okay. So all these one is negative what? 1.4. So we come and write down negative 1.4. Okay. So we say, okay. So all this give us what? Negative 1.4 equal. Look, I have to plug this in the calculator. Okay. But remember, something I'm going to get here, I will take it to the left, because look, here there's a plus. So me, this is multiply and then take it to the left. So, and then, okay, let's plug this step by step. Let me do this. These are equal sign here. Okay, 0.16 times 0.16, okay, come here. Clean our calculator quick. Okay, so we say 0.16, 0.16. Even if you say 0.16, it's the same thing mathematically. It's going to give you the same as times negative 5. Okay, so this gives us a negative 0.8. But you can plug 0.16, but it's going to give you the same thing, acceptable. So negative 0.8. Negative 0.8. Oh, so this one here is going to give us what? Negative 0.8 plus 0.2 what? Velocity of Q what? Fine. So what happened here? Look, we can take this to the right. Okay? So if you take that one to the right, it's going to give you plus, means so I'm not going to write here anymore. I'll say plus 0.8. So this is going to be plus 0.8 equal to 0.2 velocity of Q final. 0.2 velocity of Q what? Final. So divided by 0.2 throughout. So this one going to divide by 0.2 divided by 0.2. This and this cancel. So then this is going to give us velocity of Q. Plug in the calculator. Okay. Come here. Okay. So I'm going to say, okay. Come here. Okay, fraction, negative 1.4, 1.4. And then we plus 0.8. Come here, divided by 0.2. Cool. So we got negative 3. Oh, so the velocity of Q final after collision equal to negative 2. Okay, let's put this calculator aside because I don't need it. Okay. Oh, yes. Okay, so after the collision, this is going to give us equal to negative what? Negative 0, negative 3. Negative 3. Did I get negative 3? Let's check. Quick. Oh, yeah, negative 3. Okay. So the velocity of Q after the collision equal to negative 3 meter per second. Unit of velocity is meter per second. So now let me tell you something about this. Why negative? That's a question I always get every day. Why negative? Why negative, sir? I told you, eh? Don't call me sir. Call me Mchwana. My name is Mchwana. Mchwana Wabantu. What's up? How are you doing? That's cool. You see me on the way. You say, hey, sir. Just call me Mchwana. Hi. How you doing? I'm good. You don't have to call me sir. You can see me. I'm just Mchwana. So now you're going to say, okay, so, okay. So velocity Q after collision. So I can say, oh, so after Q after the collide means this Q is going to move in that direction. Why? Because negative 3. So it's 3 meter per second. This negative is to tell you that is to the left. That's why I show this arrow to the left. So you can just simply say velocity of Q. I don't have to write negative. I can say velocity of Q equal to 3. Don't put negative anymore. Meter per second, and then you can say to the west. Why to the west? Because of this negative. If you don't want to write like this and then write, you can simply write what? Negative like this. But at the moment you mention to the west and then do not write this negative, you see, move that negative. So we're done for the second one. We go for 4.22 impulse. And I like impulse. Let me show you here impulse. So we know here for Q equal to what? 3 meter per second. The reason why I show the arrow means it's negative. Now let's go for the impulse now. Impulse. Okay? Let's go for impulse. Drink some water a little bit. Okay? My mouth is dry a little bit. Sorry, phone. Okay, now let's go for impulse. Impulse is easy. Okay, that is. Now let's go. Joanna, you always say everything is easy. You always say that. Oh, yeah, it's easy. Never skip a practice day. If you don't, hey, you can fail, hey. Easy say, easy play. Now let me show how easy it is. So let me take you back face so I can understand how the impulse come. From the Newton's second law of motion, we say F net, or we have to say here Newton's law. Newton's second law of motion. Mr. Isaac Newton. So we say, okay, F net equal to mass. Do you know that? Oh, yes and no. But what is acceleration? Acceleration means changing velocity over time. So I'm going to say mass, but acceleration means changing velocity. When you say acceleration means changing velocity over changing time, or you can say velocity final minus velocity initial over time. That's meaning of acceleration. So now we're going to do the same thing game here, the same game here. So I can say acceleration means velocity final minus what? Velocity initial over changing time. So I can say F net. So this time we say F net equal to mass, but what's change velocity? Change velocity means what? You say change velocity over changing time. But remember, I'm gonna create something. I'll take this one here. Oh man, what am I doing here now? Okay, I'll take this. See this one here? And multiply here. Because I can say over 1 cross multiplication. F net times change in TOs, okay? So let me write here on top here. Equal to F net times change in time because I can cross. Equal to 1 times the same thing is going to be mass times changing velocity. It's like mass times changing velocity. But what's mass times velocity? Mass times velocity equal to momentum. See what I'm saying? So mass times velocity equal to momentum. So I can say this, let me say changing. So it's like impulse. See what I'm saying? We'll drink some water now. Equal to impulse. Sorry, my apologies. Equal to changing impulse because mass times velocity is equal to impulse. So now I'm going to say now. So impulse meaning equal to this means F net times changing time. So for that case, now the unit of impulse. So impulse meaning what? Changing momentum, or you can say force net or net force time, changing time. So let's look at it for the unit. So for the unit, is going to say unit of impulse equal to what is changing in net force. Force, it doesn't matter which type of force, is Newton. So I'm going to say the unit is Newton times what is changing time is second. So the unit of impulse equal to Newton times second because Newton is the force times second. Or if I want to say it, I can just simply say let's use the unit of this. What is the unit of mass? Kilogram. What is the unit of velocity change or just a velocity is meter per second. Oh, so this is a unit of impulse. Yes, it is. So now we understand the impulse. So the impulse simply by saying we know now what is impulse equal to F net force net times change in time or change in momentum. So now let's see, find the impulse of a ball during the collision. So the impulse, how we get the impulse? Equal to force net times what times? Change in time equal to impulse. Or you can say what? Mass times what time? Change in velocity. But for this case, the one impulse of what? The impulse of P during the collision means when they do collision. Oh, so I'd rather use this information because I don't have a force net, I don't have a time. So if they could have given me time, I was going to deal with this. But they didn't give it to me. So let me just focus on the other one. Equal to mass of what? Of P. The mass of P equal to 0.16. 0.216. times means you multiply, change the velocity of P. So means velocity final, it's like mass times what? Velocity final minus velocity initial because change initial. What is velocity final? Velocity final of P, it was what? It was 5. But I move it to the left means it's going to say this is negative because the direction is to the left, to the left, to the left, to the left, to the left. You remember that song? Or Beyonce? So now we're going to say, okay, velocity final equal to -5 because this move to the left like a Beyonce minus velocity initial of P because they say impulse of P. So velocity initial of P, we know equal to this one, 10. But I move to the right, remember this arrow, so just say 10 positive. So take a calculator, plug in the calculator. This is going to give us -2,4. So plug in the calculator. You know how to plug in the calculator, shooter. Come on, people. You know how to plug in the calculator. I'm trying to please plug in now for God. Okay, cool. Okay, so we go say, okay, let's plug it. Because sometimes you just want to see me plug in there and then you have it's okay. Let me go and plug for you. Because I know you like seeing me plug. 0,16 bracket -5 minus 10. Okay, you come here and they say, oh my God. Oh, -2,4. I got it. So now for that case, now we say, so this same is say, okay, this is what is impulse. What are the unit of impulse? We say is Newton for saying what in second because of time. Or you could have say mass. What is mass? You could say -2,4. Mass is kilogram. Velocity is meter per second. So 8 of the 2 is going to give impulse. So now another thing is, look, you know, some of you might be new here, right? So just come and subscribe here if you have not yet, so you don't miss every time when I upload a new video. This question come all the way from Josini, see, KwaZulu Natal, Debbie Natal. They sort of say, hey, Muchwana Saubo, now please help me out. I'm from Josini, KwaZulu Natal. Also, the same question come from another student from other part of KwaZulu Natal, saying, Muchwana, look, you know, you make us proud, you know, especially us. We come from. He say, yo, Chief, I appreciate what you're doing, man. You kind of inspire us. You my base one, especially when it comes to physics and mathematics. You see, I'm gonna continue watch your video. Also, I'm gonna share because you're the best. Man, really? I'm not seeing me like I'm the best or something. See, but you know what? Even though you tell me that, but I never skip a practice day. Okay? If you don't help, you're gonna fail, hey? Easy play, easy, hey. See what I'm saying? It's easy, right? So easy play, okay? Easy way, easy play, okay? Easy say. So just go start to practice, share this video. And I want to say shout out to all the students across the South Africa, students in Mexico, students in the United States of America, especially students from the South Carolina, and also students from Alabama, Mississippi, especially Keisha and all her friends and all these students teaching Mutswana, look, please don't stop. You know, you're the only one that I want to watch your video. I feel like I understand. So please, and I like your slogan when you say, never skip a practice day. If you gone hey, you gonna fail hey. Easy say, easy play. Let's go. So that's how we go, man. So don't forget to subscribe yet. If you have already subscribed, then you find yourself. But if you have not yet, please just come here and subscribe to Muchwana, man. Show us support. Let's continue this movement. Don't forget to subscribe, and there we go. So I think for today, I can stop here. See you very soon. Peace, and I'm out. Drink some water.